Okay, hi there everyone. So we're going to start with the main law and the first law that you should learn when you do electrical work, and that's Ohm's law. And Ohm's law is telling us that current through a circuit is directly proportional to the applied voltage and is inversely proportional to the resistance. However, this is only true, or this is only true if the temperature remains constant. It remains constant. So, this is how we get the formula. So, current. Okay, we first get our triangle. And our triangle, everyone should know this by now. It's V on top, and I and R like that. So, this is saying, this law is saying that the current through a circuit, so the current through the circuit is directly proportional to the applied voltage. So it's this one here. It's directly proportional to the voltage. As you can see, if you know your maths, the number on top of this, see, V over R is the fraction. And anything on top is directly proportional, and anything at the bottom is inversely proportional. So, as that means that as the voltage increases, so does the current. And as the resistance increases, the current decreases. Because our formula is written I equals V over R. So as resistance increases, your current decreases. And as your voltage increases, your current increases as well. That is the relationship of directly proportional and inversely proportional. You will see this more as you work with calculations, with the value of R increases or decreases, and the voltage as well. Okay. So I'm going to do all the laws for us, all the theory that we should know. I'm going to give everything, and then afterwards I will send a video on calculations regarding this work. Okay. So the next laws that we should know is Kirchhoffs' first and second laws. So Kirchhoff has two laws, and his first law, Kirchhoff's first law is his current law. So this law is saying that the current flowing towards a junction is equal to the total current flowing away from that junction. So what is that saying? What is that saying? So that is saying that the, okay, let's first draw a nice junction. So the current flowing towards a junction is equal to the total current flowing away from that junction. So if this is our current, let's say this is I total flowing towards that. When our current hits this junction over here, a junction is a point where your current splits. So a piece of the current will go that way, a piece of the current will go this way, and a piece will go that way. So the sum of these currents, this is I1 now, this is I2, I3. The sum of these currents will equal our total current. So this is basically the law. If you can draw this, you'll always remember the law. So the current flowing towards a junction is equal to the total current flowing. So the total of them together is our total current. That's straightforward. It's a nice and easy law to remember. And very important that you must know that if you're asked for Kirchhoffs' first law, you must know that it's the current law because he has two laws. And his second law is his voltage law. And the voltage law is saying a similar thing. It is saying the algebraic sum of all the EMFs and the voltage drops is equal to 0. So, what is this saying? So, for those of you who don't know, EMF is also a voltage. So this law is saying that the algebraic sum just means your mathematical sum. So your plus and your minus, basically. So it is saying that the sum, meaning the total of all EMFs and voltage drops is equal to 0. So this is going to be your total equals your voltage drop through maybe one resistor and voltage drop of the second resistor and the voltage drop of the third resistor. Basically, our circuit is looking something like this. Let me draw a quick thing. So it's the voltage drop here, it's the voltage drop over there, and it's a voltage drop over here. So this voltage drop is this one here, this voltage drop is this one here, this one here is that one over there. So the sum of all this is equal to our, actually to EMF, it's equal to our total voltage. So yes, so what is this saying? This means that mathematically all these equal this. All these voltage drops equals our total voltage. And for it to equal zero makes sense because we're going to say our total minus, if we bring this to this side of the equal sign, we know that the sign changes. So IR1 minus IR2 minus IR3, then this will equal zero. Mathematically, algebraic sum, mathematically this makes sense. Mathematically, so that means you must know some math skills in this. But the calculations are very simple, and we will get to them. Just to note again, when you're asked to name the second law of Kirchhoff, you must know that it's the voltage law. You must know this. Okay, so these are all the kind of calculations that you might get, and just one second, and yeah, so these are calculations you might get, and this is the voltage divider rule for number one. So let me put here 4 calculations. Okay, so 4 calculations, you get your voltage divider rule. So this is saying that if you need to get the voltage drop of resistor 1, you can use the voltage divider rule if you have the value of R1, R2, R3 and the voltage total. This is the formula for voltage divider rule. Then we have the current divider rule, and it's saying this. As you can see, here is Kirchhoff's first law, his current law in play. So the current flowing towards a point, a junction, it's splitting. Do you see it? It's splitting to I1 and I2. So I1 is the current drawn by resistor 1, and we can get the current of resistor 1 by saying R2 over R1 plus R2 times the total current. Another way, okay, we leave it for last. So I2 is the current drawn by resistor 2 because current is drawn in the circuit. So current drawn I2 we can get by saying R1 is now this resistor over the sum of these two resistors, the addition sum, multiplied by the current total. So another way to get, let's say that they ask for I1 and they ask for I2, both currents they ask for. Or let's say you were even given I2. Let's say, yeah, let's say we were given I2 and we were given I total. Yes, we can use the current divider rule and yeah, let's say we're given the resistors also, we can get the the current I1 by using this formula, yes, but we can also use Kirchhoffs current law. And Kirchhoffs current law says that I, the current flowing towards a point, meaning this, is equal to the sum of the currents flowing away from that point. That means we have I total, we have I2, and we need I1. To get I1, we use our mathematical skills, and then we take this I2 on this side and we say it will become, you can't write now, but okay. It will be I1 equals I total minus I2. This is another way of getting our I1 using Kirchhoff's current law. This is how you can play around with some formulas, some calculations, because the mathematics, it makes sense. It's the same maths, just a different formula to get the same answer. Um, once we have the current and the voltage, and the current and the resistance, we can get the voltage drop. If they ask for it, we can get the voltage drop of resistor 1. We can get the voltage drop of resistor 2. We can get these things if they ask. Okay, so the next one we're going to see a lot is going to be the parallel resistors. We know that the series resistors, you're just going to say R1 plus R2 plus R3 plus R4 plus R5 all the way to whatever number. So the only trick one is the parallel resistors. So here we have two resistors. On this one over here, we have two resistors. Let's say this number A. We have two resistors here. And to get the total resistance of two resistors in parallel, we can say R total equals R1 times R2 divided by R1 plus R2. Or we can also say 1 over RT equals 1 over R1 plus 1 over R2. When you manipulate this and you do that switching, which we'll do an example of, you will get the exact same answer. This is the beautiful magic of mathematics. On, let's say this is number B. On number B, we have three resistors in parallel. So this one requires a bit more work if we're going to use the same method as this over here. So we're going to say the resistance of, of the first parallel circuit, meaning this one over here, I use the top one here. So these top two at the top here. So R1 times R2 divided by R1 plus R2. So I'm getting the total resistance of this parallel part here. Then, you're not done yet. To get the total resistance now, you're going to say RT equals the parallel resistance, the total parallel resistance of these top two multiplied by R3 over the parallel resistance that we got plus R3. So quite the similar thing. You can do this, it's a bit longer, but you can start with any number, with any one actually. You can start with R1 and R3 first for this RP1 here, or you can do R2 and R3 and still name it RP1 and you'll get the same answer. But you just have to include it in this over here and in your second calculation, and then you also have to include the one you didn't add for your calculation. This is the only way of doing parallel circuits calculation. But you have another method, and this method is a bit more simpler. So you're gonna say it is actually one over RT. So it's 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So your calculator can do all this work for you, unless they don't use a calculator. Then you have to simplify using your mathematical methods. So, and you just do the reciprocal as your final answer to get RT on the top fraction. And you're going to have to cross multiply. But we'll do an example and then we can see how we're going to do that. But these are the formulas you need to know, like you know the Ohm's law. We have the Ohm's law, so the triangle is V, I, and R, and then V equals I times R, and I equals V over R, and then R equals V over I. This is the standard formulas we all should know by now. Um, what else could there be? What else could there be? The more we play with the calculations, the more we'll find how actually simple it is. And this is where we can actually score our free marks. Because in all papers, you get free marks. Okay, so let's do a few examples and then we see how we're gonna apply them.